after the classes I will wait. So many people is not leaving the class. It shows that they simply log in and they went out and they will do whatever they want, and after 11:45 they will come and attend the second hour class. That's all that is happening. I note down every day 5 or 6 students they didn't leave the class at all, because they don't know when the class gets over, right? They will see only 11:45. For purposely I will cut the classes maybe 11:47 or something, in this way only, right? Not in order to catch you, right? Just I want to know what kind of other side, what is your receiving capacity, right? So please take the things very seriously, because you are a 21 years old adult, right? And you mean business, right? You paid some 1 lakh rupees for this semester, and something or other, something you will get into your mind, get into your get to know about it each and every day, right? So please stick on what the instruction is given, and just to move on, right? Okay, so further I don't want to waste my time. Just I want to share my screen, and just we will continue to what we have left out, right? I hope you are able to see my screen.
Yes, sir.
Yeah, just a minute. So smart metering and other two people have taken some classes on smart meter and hardware communication knowledge and all. Today we are going to see lecture number 23, 24, possibly and 25, because all the three, 24, 25, 26 all together is a single topic, right? So this 23 as well as 24 to 26 we are going to see very small topic. And the title itself said about demand side integration. Demand side integration, that your title itself saying, right? Demand side integration. Demand side means consumer side, right? So there the demand and load is there. How to integrate all those demand side people, right? Customer side, how we can integrate, that will tell about demand side integration. And another lecture is pricing and energy consumption scheduling, right? I said, whenever tomorrow we are going to have the concept called time of use, TOU, time of use. Whenever you are using the power, you have to pay the money, right? Daytime, if you are using, much money is supposed to pay. Nighttime, if you are using, less amount of money you will pay, right? Because the demand is very less during the night time. Daytime demand is very high, therefore we have to pay much money, right? That is called as TOU, time of use. So how can people are fixing the price, that we are going to see, and both are interrelated, 24 and 25. Dynamic pricing as well as time of use, both are same. And energy consumption scheduling algorithm, that means we are going to find out the algorithm, or we are going to learn the algorithm, which algorithm will leads us to consume less amount of energy, right? That means good appliances we supposed to take it, 5-star rating equipments. Then instead of going for incandescent lamp, we go for CFL, compact fluorescent lamp. People are talking about LED lamp, that is nowadays coming up in a very faster manner. But the problem with the LED is it producing a lot of harmonics. Harmonics issue is the biggest issue of LED bulbs, right? But the people, the market is a little bit business-oriented market, right? They launched the LED, and they are projecting that it consumes less amount of power, right? One thumb rule is there, right? What amount of power is consumed by incandescent lamp? Only 50% your fluorescent lamp will consume, right? Then 50% less your CFL will consume, 50% less your LED will consume. For example, your incandescent lamp is consuming 60 watts bulb, incandescent lamp, right? 60 watts. Your fluorescent will consume only 50%. That means 30 watts. CFL will consume 50%. That means 15 watts. Then your LED will consume 50% of what CFL is consuming. That means 7.5 watts. Right? So this is the thumb rule they are following. Right? 50, 50, 50, 50. They are projecting a very less amount of power is consumed by the LED, but they fail to project how much pollution this LED is producing in the power system line. That means harmonics. Right? It is because in my room is all filled with LED. I'm projecting, I'm generating a lot of harmonics to the transmission line or to the into the power system network. Therefore, we have to use some filters, noise filters. So that is another market, right? So we supposed to buy the noise filter also. You know, this is the kind of business we are business world we are living in, right? My forefather, maybe 4 generation, right? We built a house, and in that we will not have any door at all, right? Then after that, maybe 3 generation back, they put a door. Outside we don't have any compound wall, and no gate will be there. They put a door. Then 2 generation back, we put a gate, and we put a lock also. So this generation, we have a house, and we have a door, and we have a compound wall, gate. Then we have the CCTV, right? So just see how the world is taking money from me. Four generations back, such kind of technology may not be there. Therefore, I didn't spend any money at all in my home. People are good, and people are all those things were good, right? My money was not consumed by the corporates. Nowadays, whatever money I'm getting, all those money I will give back to the people. Have you got what I'm talking? The same way, nowadays they have launched LED here, and tomorrow they are going to tell that you are polluting a lot of noises because of the environment. Therefore, you have to put the filter. Therefore, I have to buy the filter also. Right? So these are the things. How can I reduce the energy consumption? Scheduling algorithm. How can we schedule? So my washing machine has to schedule at 1 a.m. My dishwasher has to schedule at 2 a.m. My AC will schedule from maybe 10 p.m. to 6 a.m. So in this way, how can I schedule so that I can reduce my bill? So that is the concept behind the 26, right? So this is the just introduction about the 23, 24, 25, and 26. So we are going to see one by one. First, we are going to see demand side integration, right? Demand side integration. Demand side integration is a set of measures to use loads and local generation to support network operation and management, improve the quality of the power. Right? Demand side integration is nothing but to measure, to use the load so that my power quality will be increased. So in what way I can integrate, or what way we can integrate local generation. Local generation means my solar power and as well as wind power. These are the local generating unit, and what kind of load I'm using. So I integrate these two so that I can improve the power quality. For example, in my home, I'm having good solar, and I'm using some CFL, right? My power quality will be very good. Actually, for example, your home is here, neighbor is your next home is your neighbor already. I mean, we know that, right? So if you are using very low quality, low standard equipment in your home, right, you are generating a lot of pollution, a lot of harmonics to the transmission line that will go to your neighbor. So neighbor also using very low standard equipment, and they are also producing a lot of noises, a lot of harmonics that will go to the next neighbor. So in this way, everyone is polluting the grid. Everyone is polluting the power system network, right? That we should not do. That is each and every person's honesty and reliability, and as well as their maybe what is that responsibility. I should not use any low standard device in my home. That responsibility every citizen has to take. Otherwise, the quality of the power we cannot maintain. Power system will not produce any harmonics. As a customer is producing harmonics. Customer is producing a lot of noises in the power system network. That's why the TNEB and other people are insisting you must use five-star rated refrigerator, 5-star rated washing machine, right? Cost is a little bit high, of course, I agree. But we should not pollute the atmosphere. We should not pollute the power system network. 5-star rating. If you go for five-star rating refrigerator, the cost is 20% than the 3-star rating refrigerator. But the quantity of harmonics produced by this 3-star rated refrigerator is very high. That will produce a lot of harmonics. You may ask, so what is the use of harmonics? Yeah, I already have said it. Almost 90% of our electronics equipments, not only electrical, all the equipments is run by switching devices, power electronic switches. Power electronic switches need exactly 50 hertz sinusoidal. Then only all my IGBT, then all my thyristor will fire at a right angle, right? If the pollution is there, if the harmonics is there, the frequency will be 49.5 or 49. So it will lead the power electronic switches in a wrong manner. So wrong firing angle will be there. Therefore, wrongly the switches will be on and off. Therefore, all my electronic gases will go off. So that's why I have to bother about the harmonics, right? So we have to be so responsible. Therefore, in my home, I have to use five-star rated equipment. I have to use what's government. That means BIS, Bureau of International Standard. BIS, what BIS is saying, and what the IEC standard is saying, all those standards we must follow. Otherwise, we will pollute the power system network. So in what way we are going to, we have to follow this one, we are going to see in these slides, right? There is nothing but demand side integration, right? So what I have told, it is there. This is, for example, demand side integration. This is the y-axis, this is the x-axis, this is time, right? In what way I can reduce the, in what way I can improve the power quality? That is the objective of my demand side integration. The main objective of demand side integration is how to improve the power quality, right? For example, this is the load duration curve. This is called as load duration curve. This is load, this is time. For example, here I am having some peak load. Okay, so this is a peak. See here, this is a peak for maybe 15. This is 16 to 22. 6 hours, the peak load is there. If I am maintaining 6 hours peak load, maybe my quality of the power will be poor. Therefore, what can I do? I can shift. I can shift this peak power to somewhere here, because here very poor load. So that time I can use the power here. Therefore, I can avoid such kind of peak for 6 hours, right? So for example, this is 6 o'clock to 20 minutes, evening 10 o'clock, right? For example, I'm using washing machine here, right? Instead of using the washing machine here, I can use the washing machine here. Therefore,